Figure it out.
So this is our intake prototype so far, or prototype, but it might just go on the robot if it works. We have two pivoting grabbers. These are going to be motorized flywheels that should intake the cube and the cone, so we have just one end effector for both game pieces. Here's roughly how it's going to work for the cube. So these will spin and clamp, and it should stay pretty well in there. And then for the cone, we're going to have to clamp a little bit more, but we do have a, here, if you want to show this. So we do have a backstop with this piece of Lexan here for the cone, and then we're also going to add a stopper up high. We're going to see how it works to put some sort of object here that'll stop the cone from rotating like this, and then with the clamp force it should be held in pretty well. The thing that we still need to figure out is how we want to clamp it. There's a few different ways we could do it. We could have some sort of stretchy surgical tubing like this. We could have that pull these together, or we could do a piston back here to push them apart, or maybe even a spring or springs on the pivots. So we're going to prototype some more, see what works the best, and then hopefully we'll be good.
Okay, now we're going. Oh. Hey!
So here's intake after a little bit of update. I was testing out how this backstop, hardstop mechanism, not a mechanism, but I was testing out how this backstop would work on the cone, and it looks pretty good. So as long as we have a lot of clamping force, this is it.
Well, as you can see, sometimes.
So there's a little, there's a couple changes. One thing I think we should do is take this Lexan at the bottom and bend it up to a lip. That eliminates that problem. We would also make it pretty grippy, make this grippy. It's still gonna have a lot of clamp, but this is exciting so far. The shape is nice. One thing that is a little bit of an issue right now is that
Don't pop it. Don't pop it. Don't you dare pop it.
Is that there's a chance of it popping. Because this is low and this is thin and it's also sharp. So it goes in, but yeah, there's a chance that could get popped. Two things we could do. We could make this curve kind of like that, so that the cone will still hit that curve, but there's no sharp edges. Another thing we can do is take this, mount it higher, have it come out a little farther, so that it just goes over top the cube, and that's probably what we're going to end up doing. Just have this hard stop come up, and it'll just hit a little bit higher on there. But yeah, good progress so far.
And other than that, at this point, we've also determined that we're probably going to build this more as a budget thing, going for the lower thing. That's an update on the strategy side of things.
Yeah, we're not going to shoot for the higher pull, because that's basically the same thing as what we're doing, but it would just be more resources and more time.
We don't have the resources to go for the high one with what we currently have, essentially. We could. We have an idea that would work, and I'm certain scaled up, and with a little bit of editing, could potentially get us to the high. Probably show that off tomorrow, or heck, maybe in a moment if I go to like a CAD cut through, because that's getting done tonight.
Okay, it's 2:30 a.m. I'm tired, and it's time for the CAD lightning run now that our robot CAD is in some state, something at this point. So to start off, over here we have our claw mechanism, our pickup. Right now we plan on adding some sort of piston or maybe surgical tubing or something to help it clamp shut or clamp open. And that's just how we plan to pick stuff up right now. We also have it on this hinge right here in the CAD, and that is because we're trying to figure out some way to passively, when it's down low, level it off with the floor so it's easier to pick up downed cones and other items like that. Moving on from there, we've got the elevator system, and the elevator system, it It's basically a thrifty bot elevator slash climber in a box style mechanism on a pivot connected right here. Motor's down here for that, acts as a nice counterbalance, and motor to drive our pivot is down here. This is like I don't even know at this point, like a 400 or something calculated. And yeah, that's roughly the quick rundown.